Assalamualaikum Nahai. So now we are going to look at question 7 from tutorial chapter 8. So what we have here is a figure 8.5 shows a string wound around a wheel with a free end of the string tied to the shilling. So one end is tied to the shilling and another one is wound around the wheel. The mass of the wheel is 0.5 kg and radius of 40 centimeter. So it has a radius of 40 centimeter and a mass of 0.5 kg. When the wheel is released, so now as it is wound around here, and when you release, dia akan unreel itself. It will fall downwards and at the same time rotate. So basically what happened, initially it was wound around the wheel, and then dia punya tali yang kamu lilit sekeliling dia itu, macam kita main yo-yo, terbuka. So bila terbuka, what is going to happen adalah dia akan turun ke bawah. So the wheel is going to go down like this. Okay, bentuk dia macam gini lah. Macam yo-yo tu. Okay, so as it goes down, it did not only displace from this position to this position, it also rotate. The wheel also rotate dekat sini. So dia akan alami dua jenis acceleration, iaitu linear acceleration untuk dia turun ke bawah. The object displaced from this position to here. So dia akan alami linear acceleration. At the same time, the wheel also rotates. Okay, dia akan undergo rotation. So bila dia undergo rotation, dia akan rotate in this direction so that the string unwound itself. So dia akan ada angular acceleration juga dekat sini. Okay, if the moment of inertia of the wheel about its axis of rotation is 0.2 kg, so this wheel has a moment of inertia of 0.2 kg m square. Calculate the linear acceleration of the wheel and the tension of the string. So kita nak cari apa dia punya acceleration dan juga tension in the string. Okay, so let us redraw our system here. We have a string and the wheel here. Kita ada string dan juga the wheel here. So this wheel here will experience angular acceleration alpha here. So bila dia ada angular acceleration, so obeying the Newton's second law for rotational motion, kita akan ada summation torque is equals to summation torque is equals to I alpha. This is the Newton's second law for rotational motion. At the same time, the object has also displaced, the wheel has displaced and undergo linear acceleration. Maka dia akan obey Newton's second law of motion for linear motion, iaitu summation F is equals to MA. Okay, so for summation F is equals to MA, objek kita dekat sini adalah the wheel itself. So this is the wheel. So the forces that is acting on the wheel adalah the weight of the wheel. Kita ada W. Dan juga kita ada tension from the string, kita ada tension dekat sini. Okay, and the object has been displaced downwards sini. This for summation F is equals to MA here, and the question also asks to find the acceleration and also the tension here. Okay, so force yang kita ada adalah tension dan juga weight. The tension is going up, so positive tension, and then plus dengan weight is going down, negative W, and these two must equals to MA, the mass of the wheel, multiply with the acceleration. So mass dengan acceleration downward, so negative A. So now I'm going to substitute all my known value. T minus W here is the mg 0.5 multiplied with 9.81 equals to negative 0.5 acceleration. So as you can see, you have two unknown here, the tension. Let me quickly press the calculator to find the value for 0.5. I think it's 4.905 here. Is equals to negative 0.5 A. So since we have two unknown here, we are stuck here. So what are we going to do is we are going to use the information from the Newton's second law of motion for rotational motion in order to help us to find the tension and the acceleration. So as the object is rotating, okay, as the object is rotating, this rotating object experience two force, tension and also weight of the wheel itself, sama juga. Okay, however, since it is rotating dekat sini, the axis of rotation adalah dekat tengah-tengah sini. The axis of rotation dekat tengah-tengah sini. So kita akan alami dua torque disebabkan kita ada dua force. So torque due to the tension campur dengan torque due to the weight akan sama dengan I and I alpha. Yes. Okay. So torque here, as we know, torque is equals to R F sin theta. Okay, RF sin theta. So let us first look at the torque due to the tension here. So the R here, let us draw this much clearer dekat sini. Saya lukis balik, kita ada tali. This is the tali. And then this is your wheel here. Okay, the R here is the distance from the pivot point ataupun axis of rotation to where the force is exerted. The force is exerted on this particular point. So ini adalah R kita, which is basically the radius of the wheel, iaitu 0.4 cm. 40 cm, 0.4 meter here. 0.4 meter. And then F kita dekat sini adalah the tension itself. Sin theta adalah angle antara R dan juga T kamu. Is the angle between the R and also the T, which is 90 degrees. Sin and 90 gives you 1. However, you must consider the direction because torque is also a vector quantity. If you pivot at this particular point, kita dah paku iaitu axis of rotation dekat kawasan sini. Awak tarik, you apply a force tension dekat sini, your object has a tendency to rotate in this direction. Okay, this is a anti-clockwise direction, maka dia positive dekat sini. So you will have a positive sign here, plus with, and your torque due to the weight, the torque due to the weight is acting exactly on the axis of rotation. Sebab dia berlaku pada axis of rotation, dia punya torque jadi kosong dekat sini. So we do not have torque due to the weight dekat sini sebab nilai dia jadi kosong. And then I adalah the moment of inertia of the wheel, which is given in the question sebanyak 0.2. Alpha here, your object is rotating in the anti-clockwise direction, maka dia punya direction adalah positif juga. So dia jadi I alpha, which is also an unknown dekat sini. However, we have relationship such as alpha here is equals to A over R here. A over R here. Ini adalah alpha. So now what I'm going to do is I'm going to substitute this into here so that my second equation also has the same unknown as my first equation. Supaya saya boleh do simultaneous equation here. 0.4 tension is equals to 0.2 A over R. R is a radius of the wheels, which is 0.4 here. So saya akan dapat 0.2 divide 0.4, 0.5 A, 0.4 T. Okay, I'm going to make my T as a subject dekat sini. T akan sama dengan 0.5 bahagi 0.4. You'll get 1.25 A. So I'm going to substitute this into here now. So my tension is actually 1.25 A minus 4.905 is equals to negative 0.5 A. So I'm going to bring this one to the left. Ini ke kanan. Ke kiri. Ini bawa ke kanan. So I'm just going to rearrange this lah kan. Supaya I put all my unknown on one side. Negatif bawa ke kiri dapat positif 0.5 A. Negatif bawa ke kanan dapat positif 4.905 here. So now I can sum this to 1.25 plus 0.5. I get 1.75 dekat sini. Betul tak? And then I'm going to divide 4.905 divided with 1.75. I should get my acceleration such as 2.8028, which round off dapat this much acceleration. So ini adalah acceleration at which the wheel is going to go down and displace from this position to this position. So dah dapat acceleration. As you can see, the question also asked to find the tension in the string. So I'm going to substitute this into here to find my tension, where tension is basically 1.25 multiplied with 2.803. 2.803 darab 1.25, we should get the Newton as 3.50 Newton. So this is the tension experienced by the string in the